Have you ever wondered what would happen if you could remove absolutely everything from a place? No air, no dust, no light, no planets, no stars, not even a single atom. It sounds like you'd be left with nothing at all. For centuries, people imagined that somewhere out there, perfect emptiness must exist, a place where absolutely nothing remained. It seems like a simple idea, but it turns out that defining nothing is far more difficult than it sounds. As science advanced, that seemingly straightforward concept became one of the biggest surprises in physics. So why isn't empty space really empty? The more closely researchers examined empty space, the more unexpected discoveries they made, challenging everything we thought we knew about the universe. Let's dive into it, right here, on History of Simple Things. The idea of empty space has fascinated thinkers for thousands of years. Ancient Greek philosophers debated whether a true vacuum could even exist. Aristotle argued that nature would never allow complete emptiness, believing that any void would instantly be filled. Centuries later, scientists began testing those ideas through experiments instead of philosophy. By the 1600s, inventors such as Evangelista Torricelli and Otto von Guericke demonstrated that air could indeed be removed from containers, creating vacuums. These discoveries showed that space without air was possible, but they also raised a deeper question. If you removed every visible substance, was that truly nothing, or was something else still there waiting to be discovered? For a long time, the best vacuum humans could create seemed close enough to perfect emptiness. Modern vacuum chambers remove nearly all gas molecules, allowing scientists to study materials without interference from air. Yet even these chambers are never completely empty. A handful of atoms always remain, and tiny amounts of radiation continue passing through. More importantly, these laboratory vacuums are still surrounded by Earth's gravity, magnetic fields, and countless invisible influences. Even in the vast emptiness between galaxies, where only a few atoms may occupy an entire cubic meter, space itself continues to possess measurable properties. Scientists gradually realized that removing matter does not erase everything else that exists. The biggest shift came with Albert Einstein's theory of general relativity. Before Einstein, many imagined space as an invisible stage where events simply happened. His work showed that space and time are woven together into a single fabric called space-time. Massive objects like stars and planets bend this fabric, and that curvature is what we experience as gravity. Earth orbits the sun not because an invisible force pulls it through empty nothingness, but because it follows the curved geometry of space-time. Even if every atom disappeared from a region, the structure of space-time itself would still remain. In other words, what seems like empty space is actually part of the universe's physical architecture. The story became even stranger with the arrival of quantum mechanics during the 20th century. According to quantum field theory, every type of particle is associated with a field that exists everywhere throughout the universe. Electrons, photons, and other particles are temporary excitations of these underlying fields. Even when no particles are present, the fields themselves remain. Because of the uncertainty principle, these fields cannot stay perfectly motionless. They constantly experience tiny fluctuations, producing what physicists call vacuum fluctuations. These aren't miniature objects randomly popping into existence in the science fiction sense, but measurable effects arising from the behavior of quantum fields. This means that even the emptiest possible vacuum still contains restless activity beneath the surface. This strange picture is not merely theoretical. Scientists have observed real phenomena that match these predictions. One famous example is the Casimir effect, first predicted in 1948. When two extremely smooth metal plates are placed incredibly close together in a vacuum, they experience a tiny attractive force caused by changes in the quantum fields between them. Experiments have repeatedly confirmed this effect with remarkable precision. These discoveries show that the vacuum has measurable physical consequences, proving that empty space behaves more like an active environment than an absence of everything. Understanding that empty space is not truly empty has transformed modern physics. It influences how scientists think about the origins of the universe, the behavior of black holes, and the mysterious force known as dark energy, which appears to drive the accelerating expansion of the cosmos. Researchers continue studying the energy of the vacuum because it may help explain some of the biggest unanswered questions in science. Although many details remain unresolved, including why theoretical predictions of vacuum energy differ so dramatically from observations, the realization that nothing possesses structure has reshaped our understanding of reality. Empty space is no longer viewed as a blank backdrop, but as an essential ingredient of the universe itself. Perhaps the most surprising lesson is that the closer we look, the harder it becomes to find true nothingness. What once seemed like the simplest concept imaginable has become one of the richest areas of scientific discovery. Empty space is filled with geometry, invisible fields, subtle fluctuations, and physical laws that quietly shape everything from atoms to entire galaxies. It's a reminder that reality often hides its greatest mysteries in places we assume need no explanation at all. Sometimes what appears to be nothing is actually where the universe has been keeping some of its biggest secrets all along. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.